Hi friends, I'm going to do alloy wheel core rim modeling by using Creo. In that, just open Creo 3.0 and then name it as core rim, and then by using revolve option and by clicking the front view, and then by selecting the front plane, then put center line, and then give the construction line so that it won't be considered as a regular line. uh, the axis from the center line is about 30 mm, and then draw a straight vertical line, horizontal line up to 40 mm, and then a slanting line of 10 degree from the axis. And now measure the slanting line, it should be 30 mm, and then another one horizontal line, it should be about 20 mm, and then again just make a construction line of 150 mm, and then a height of 30 mm, and then a vertical line of 30 mm up to that axis, and then again we want to draw 30 mm, and both should be straight, and then another slanting line which is parallel to the previous slanting line, it should be 10 degree, and it is having a height of 45 mm, and then make a 3-point circle, fix the first end and then second end, and the arc center of the circle should be in the construction line. Remove those unwanted lines, and then again you just click on 3-point arc, it should be in the center line, and then remove those unwanted lines, just trim it and click OK, and then we get the revolved outer surface of the rim, and then we are using bottom plane. We want to cut down for the alloy wheels. Click on reference and then select the outer circle, draw a straight line to the center of the axis, two vertical lines, then measure the line, it should be 150 mm, and then connect those two ends by using arc command so that we can throat cut, and then make fillet, it should be of 10 mm. Click on OK. The sketch should be in the middle plane, and the extrude should be 300 mm. We want to cut the material, select OK. Yeah, now we have a select a pattern, then want to select the axis, click the center axis about 360 degree, the pattern should be 8, and then click OK. Yeah, now we get outer line, and then click on front view. This revolver is to have the bolt hole. Click on the center line. It should be away from the actual center line. It should be 30 mm. And then click on line. The given sketch should be drawn on the left hand side. Complete the sketch and then modify it. The small line should be of 15 mm, then baseline should be 10 mm, and then vertical line should be of 40 mm. Click OK. Want to remove the material, just pre-check it and then click remove. Yeah, there we get the hole. Select the axis and then for a 360-degree we have 6 patterns. Then click on OK. We want to draw the outer surface, so that click on front view, click sketch. We want to revolve it, so revolve in the plane, and then for that center axis should be needed, and then take the reference point and then draw a line, a vertical line. So that this is the outer surface rim. So by revolving it, it should have a rim base. The small line should be of 20 mm, and then the total length is of 150 mm, 10 mm, and then 15 mm. Yeah, it's look nice. Click on OK. Yeah, we get the outer surface base rim. So this is the rim. We want to convert it as step file, and then we want to import it in the hypermesh OptiStruct we are running. Yeah, click on OK. Import the model, which we have save it in the step file. We want to import it in the step format. So hyperworks tutorial core rim step, open, and then select import. Then the given model has imported. Click on model. Yeah, first of all we want to save the model. It should be of extension .hm, so I am saving it as core alloy .hm. Click on save, and then we want to view. If you want to edit, we want to click make current for the given component. We want to mesh it, select 3D tet mesh, volume tetra, element size should be 6, and then click on mesh. It will take time, since tet mesh it will be taking time. Yeah, we got it. The mesh should be so fine. So we want to create a rigid so that we have and then we want to create load collector, and then we want to create material for the alloy. I want to create the property also, and then create a load step to run the file. First of all, we want to make the rigid. We can take the center of the alloy wheel. Uh, for that function F8, we want to make a center node, so that I'm just clicking, and then 1D rigid. I want to select the node, and then we want to select the surface also, so that I am selecting the inner surface. And then in load collector, I want to create an SPC, single point constraint, so that it should not move in any direction. We want to fix it in the all direction. 3D constraint, click on the node, and then all the degree of freedom should be locked. And then we want to create a point load, so that if any stone which hit the aluminum, it should be bending. This is our main background. Then analysis force, and then I'm just creating a point load over the rim. I'm giving load on a Z axis, negative side of Z axis. Click on create. Yeah, these are the loads I have created. And then in load step, its analysis should be generic, and then SPC load should be of force. Then material, as material we consider this material as aluminum, and then click on the smallest, and then Poisson ratio, the aluminum density 2.75 e power minus 9, that is 10 per mm cube. Property, it should be solid one. Be solid, and select the material. Assign the material to the component aluminum, then save it, then click on analysis, OptiStruct, and then solver view will open, and then it will solve the solver by using OptiStruct solver. The point load which we are acting on the outer surface of the rim, we can calculate for yeah, analysis is completed. Click on result, and then a hyper view window will be open. We can see the results. Then click on the displacement. that if you apply a point load over there, it should be bending